In this segment, we're going to talk more about the demand function. Remember, the demand function gives a relationship between the price of a product P and the quantity Q that consumers will purchase or demand at that price. So a demand function is in the point of view of the consumer. So if you think about price and quantity as a consumer, as a price increases, demand for the product decreases. Things get too expensive and people don't buy as many. And as price decreases, consumers demand more goods or more of a product, more of the product. So because of this, we can say in general, demand is a decreasing function. Now you can talk about an increasing function or a decreasing function, but it usually helps to look at this in terms of a graph. It's easier to talk about things increase and decrease if you have a picture to look at. So let's look at a couple of functions and see as prices increase, the demand decreases, or as price decreases, demand increases. Let's look at this function. Q of P is equal to 40 minus 0.4P. Let's look at a graph of this function. P is the input, so it goes on the horizontal axis, and Q is the output. Typically, you always want to use an intercept, so we'll let P equal 0, and if P is equal to 0, Q is 40. We'll call that 40. So that's our first point. As we go on and pick values for P, as we multiply, we're subtracting them from 40. So our values are getting lower for Q. If we go over to, say, P equals 100, if I multiply 100 times 0.4, I get 40. So my quantity has dropped to 0. So I have a linear function and it's decreasing. And if you think about it, as P increases, that means P is moving to the right. As P increases, our quantity decreases. So P increases and Q decreases. So it is a decreasing function. Now this is very easy to see if you have a linear function. Demand does not always have to be linear. We can have much more complicated functions. Quadratic, you'd have the downward part of a parabola. Even exponential. Let's look at the function P of Q equal to 100 minus e to the 0.1 Q. 0.1. I know that looks like a messy function, but let's see if we can possibly put in a couple points and get an idea of what it looks like. If you remember from exponential functions, like linear, either decrease or they increase. So let's see what this one looks like. And I'll start with Q equal to 0. Q is the input on the horizontal axis. P is the output. If Q is equal to 0, 0 times 0.1 is 0. E to the 0 is 1. Let's look at that. 100 minus e to the 0.1 times 0. 100 minus 0.1 times 0, e to the 0 is 1. That means that the price is 99. So if I have 0, I go up to, we'll call that 99. So if no items are sold, the price is $99. It doesn't really make much sense, does it? about what the shape of this is going to be. If I put in Q equal to 45, I picked 45 for a very particular reason. If you take e to the 0.1 times 45, e to the 4.5, you get a value that's about 99. 90 or 99. So my value drops over, I'll call that 45. And in between, we have a curve. It's exponential, and then it drops like this. So if you plot a few points in between, you can see the general shape of it. It is decreasing. Now, I can't go much beyond 45, maybe 46, before it drops below the axis. The same back here. If I go beyond 100, it drops below the axis. But remember P and Q. P is price. Price is positive. You can't have a negative price. Quantity is positive. So we have to keep our prices and quantities positive, so we have to be very careful with our domains. For this function, my domain is from 0 to 45 to 100. 0 less than or equal to P, less than or equal to 100. Over here, the domain, we went as far as 45. I think you might be able to get up as far as 46. I don't think you can go much higher than that before Q drops. The value for price becomes negative. So you have to watch out for your domains in these. But these are what demand functions generally look like. They are decreasing functions. A supply function gives a relationship between the price of a product P and the quantity Q that suppliers are willing to provide for sale at that price. So a supply function is also a relationship between P and Q, like a demand function. But the demand function is from the point of view of the consumer, and a supply function is from the point of view of a supplier. So in general, a supply function is increasing because at a higher price, we'll have producers or suppliers putting more on the market. Whereas when prices are low, for example, if things go on sale, suddenly there's a scarcity of items. They don't want to supply as many at a low price. So let's look at a couple of graphs. Suppose I have Q equal to 5P minus 375. Positive slope. This is the linear function. The slope is positive. So if we graph it, P on the horizontal axis, Q on the vertical. In this case, you can't really put in P equal to 0. If P is 0, quantity is a negative 375. Quantity can't be negative. If we put in P equal to 75, remember that these points will be PQ. Put in 75 for P. 5 times 75 is 375. Minus 375 gives me 0. So at a selling price of 25, a selling price of 75, we get to where Q is equal to 0, and then for numbers bigger than that, we'll have values for quantity. Let's jump up to 200. If I plug 200 in here, I have 5 times 200 is 1,000. 1,000 minus 375 gives us 625. So if P is a price of 200, then I have a value of 675, increasing. If P is a price, Q is the quantity, at a price of $200, we'll we'll have 625 items available for purchase. But at a lower price, there will be fewer available. So in this case, as P increases, it's a funny arrow, isn't it? That's better. Our quantity Q also increases. So the supply function is an increasing function. Well, let's look at a nonlinear supply function. Let's look at, this is P equal to 0.1 x squared, Q squared, plus 2.2Q plus 22. This is quadratic. That means the graph will be a parabola, and the positive number here tells us it opens up. So let's get a couple points going here. Q is my input, P is the output. If I let Q equal 0, I'll get P equal to 22. Price of 0 doesn't really, a price of 22 would be what we'd have if quantity were 0, then you wouldn't have sold anything. Nothing would be available. So let's look at a price for 1. If Q is equal to 1, I've got 22 plus 2.2 is about 24.2, plus another tenth is 24.3. So if one item is available, the selling price of it will be $24.30. So here's 1, here's $24.30. Let's say Q is 10. 10 works with decimals here. 10 squared would be 100. 1/10 of 100 is 10, plus times 10 would be 22, plus 22 gets us to 54. So if I have one item sitting on the shelf at $24.30, that's what the suppliers gave, it's sold. But if there's a demand for it and this item comes in at $54, the suppliers hope that 10 will sell. So they want to sell more at a higher price so that our supply curve, here again, 10, is increasing. And it's a parabola, so it opens up. Now it's 10. Okay. So in general, a market equilibrium occurs when supply equals demand. Consumers are willing to buy exactly what suppliers are willing to supply. This intersection is called the equilibrium point. So let's look at a demand equation and a supply equation and find it. Our demand equation, D of Q, P equals negative 0.67 Q plus 1060. The supply equation, S of Q, P equals 0.50 Q plus 570. And we set them equal to each other. We can distinguish between the two because demand has a negative slope, supply is increasing has a positive slope. Negative 0.67 Q plus 1060 equals 0.50 Q plus 570. So I combine my constant terms, subtract 570 from 1060, and I get 490 equals, add 0.67 to 0.50, I get 1.17 Q. When I divide 490 by 1.17, I'll get 418.80 and some other decimals. So our quantity really should be in an integer, but for now, let's leave it with a 0.8 so we get a more accurate price. And you can find the price by plugging the quantity into either equation. Let's look at the second one. P equals 0.50 times 418.8 plus 570. Multiply it out, add it together, I get 779.4. So that our equilibrium quantity, we'll round it now, equals 419, and our equilibrium price would equal $779.40. Now, this is the equilibrium point, the Q and the P. In the lesson, there's a really good explanation of this graphically with equilibrium points and supply and demand equations, and also a very clear definition. So please look at those. Thank you.